Good morning, everyone. Today, I'll be presenting our work titled Engineering Biomaterials for Women Health Application, Functional Design and Innovation Pathway by Cecilia Treviño-Quintana and Liliana España-Sánchez. This chapter was developed at Tecnológico de Monterrey and focuses on how biomaterials and polymer nanocomposites can transform women's healthcare, making it more personalized, inclusive, and sustainable. Over the past decades, the study of women's health has evolved toward a more holistic perspective. We now recognize that women that have unique physiological, hormonal, and social characteristics that demand differentiated prevention, diagnosis, and treatment strategies. Many conditions have historically been underestimated and misdiagnosed due to the lack of female representation in biomedical research. This has encouraged the development of personalized medical technologies, particularly those based on polymeric materials that combine biocompatibility, biodegradability, and adaptability for physiological stimuli. Women face a wide spectrum of health challenges, both chronic and gynecological. Among the most significant are cardiovascular diseases, breast cancer, and metabolic disorders such as type 2 diabetes. We also highlight mental health, osteoporosis, endometriosis, and ovarian insufficiency, all deeply connected to hormonal regulation. Understanding these diseases is fundamental to designing biomaterials that can respond to each stage of woman's life. Another key challenge is inequality in health access, particularly among indigenous and rural women. They face economic, geographic, and cultural barriers compounded by institutional gender bias. To address this, we need transdisciplinary solutions, integrating technology, biology, and social awareness. Here, functionally polymeric materials play a vital role, offering tools to create personalized therapies and diagnostic systems designed with a gender's perspective. Women's health is dynamic. It changes from puberty to menopause. Each stage brings hormonal variations that affect mental, reproductive, and metabolic health. Polymeric nanocomposites have emerged as versatile materials capable of delivering targeted long-term and safer treatments. They are being explored for hormonal therapies, cancer detection, contraceptive systems, and treatments for endometriosis and fibroids. These materials combine natural polymers such as collagen, chitosan with synthetic ones like PEG or PSL, providing both flexibility and functionality. Let's look at some concrete examples. Number one, we have a hormonal and reproductive health example, an intrauterine device that provides a 4-week sustainable hormone release, improving adherence and minimizing side effects. Number two, a bone regeneration in menopause. 3D printed scaffolds combining PETG, chitosan, hydroxyapatite, and folic acid support bone cell growth in osteoporotic patients. Number three, preterm birth preventions. Microneedles patches made from PDMS allow sustainable progesterone delivery, reducing premature labor risk. All of these innovations show how nanocomposites bridge diagnostic drug delivery and regeneration medicine. Polymeric nanocomposites offer a personalized, biocompatibility, and sustainable approach to women's healthcare, bridging diagnostic, drug delivery, and regenerative medicine. But despite the progress, major challenge remain. We need devices with high physiological specificity, biocompatibility, and control localized drug release. Scalability is another concern. How to mass produce nanomaterials while maintaining uniformity and safety. We also face regulatory gaps regarding nanostructure in medical devices, and beyond the lab, social acceptance is essential. Overcoming cultural stigmas through education and awareness will determine how these technologies are adopted. To conclude, the future of biomaterials in women's health depends on a holistic, gender-responsive approach. We must design systems that are biocompatible, biodegradable, and non-toxic, yet responsive to biological cues, scaling up production, validating through realistic models, and harmonizing regulations and crucial steps. But above all, interdisciplinary collaboration, ethical innovation, and education will ensure that these advances lead to equitability, accessible, and sustainable healthcare for women worldwide. We would like to acknowledge Tecnológico de Monterrey for its support and collaborative research that made this chapter possible. Thank you very much for your attention.